Welcome to Solar Study course. In previous lecture, we have seen about the module datasheet. From that module datasheet, how we can generate the solar IV curve for the different irradiation and for different temperature. So there we have used inbuilt library that is called PVlib. Using that PVlib, we have imported some of the model datasheet, that is a Canadian model of the solar datasheet. We have imported, we have added that value, and we have generated the IV curve of that particular model. So in this lecture, what we will do, we will generate the model IV curve by using model data. What is the model data? First we will see that one. So what and all we will do here. First of all, module is manufacturing in the industry, solar industry. They are fabricating and all the packaging is done. What they will do before sending to the customer or before installing, they are doing the sum of the test. That is called laboratory test. This kind of test is called as a flash testing. So what will happen after manufacturing? We can't put directly in the field. So before putting in the field, there do the flash test. In flash test, they are injecting some of the radiation which is equivalent to the solar radiation. So in the laboratory condition, there will be some of the test bench there where they put the module and they are injecting the light and they will calculate the all the voltage and current, whether all the voltage and current and power which is coming out of the module is same as what is actually designed, what are the rated data sheet present. Like suppose I am using 220 watt module, so for there they have mentioned VOC is this much, ISC, so many things are mentioned. So after putting in the field, whether I will get the same data, so for that reason they are testing, so that is called a flash test. So we are getting the sum of the flash test data. Okay, so using this data we can generate the model IV curve. So there are two things. One of the thing is using datasheet we can generate the IV curve. Another thing, using module data, that is one of kind of the comma separated value or Excel data. So using that Excel data, there may be around 1000 points of voltage and current. From there we will generate the model IV curve. So let's start this lecture 23. Welcome to lecture 23. We will do the model IV curve. Myself Karthikeyan. Let's start the SCADA data. What and all data or flash tested data it will containing. So we will go through that one. Then after that we will use Python programming, use plotting the model IV curve. So let's start with the data. So here I have opened the one of the data. This is nothing but what this is flash tested SCADA data. Here what we will getting, so while we will put the model in the flash tested bench, it will inject some light. So according to that light it will generate some of the data. See here you can see. So what it will give, this is give some comment and some ID. This is nothing but module ID. It will enter and title is demo. I have given the demo. Then which type of a module, type 1, type 2. What is the type 1 and type 2? That is nothing but polycrystalline, multicrystalline. This is multicrystalline, so that's why type 2. Like in some of the other testament there may be type 2 may be monocrystalline, there may be differ. Then time duration, at what time I have taken. Then what is the date and irradiance. See this is for 100 watt per meter square and corrected in irradiance, that is nothing but 100. And what is the lamp voltage? Like in order to generating the that much of rays, it requires some of the voltage, that is nothing but lamp voltage. Then corrected to the temperature. Then what is the module temperature? This is for STC condition 25.73. What will it will correct? It is again corrected to the 25.73, because while doing the flash test they are doing not only one times, 3 or 4 times. So again you will see the corrected temperature is 25 degree. Then MCC, that is also one of the parameter, that is 0.93 module corrected parameter. Then open circuit voltage, what is that one? 16.47. Okay, then ISC 8.52. Then series resistance, and what is the shunt resistance, what is the maximum power, because here we have used some of the degraded power, like I'm thinking, so that's why it is generating the 979 watt. Then VPM, IPM, fill factor, what is that, it will give that one. And active efficiency, how much efficiency, this is 5.5. Okay. And some of the effect like aperture effect, segmented area, how much area, model area. Then segment in series, 60 cells in connected in series, how many panels, only one panels. And panel area, this is in centimeter. Then what is the load is connected at the output, there is no load, even like PV load, IV load. And frequency, at what frequency light is incidented, 27 4000. Sweep delay, this and all some of the data. If you just go through about the flash testing of the module, you will get the all the detail. So this is just a SCADA data which is getting from the flash testing. So here again we will get the pulse width, some of the current, voltage, active, like it is the second time. So this flash test will happen only in the duration of 1 second to 2 second. Only that's it. There will it will inject the light and again it will turn off. So at that duration it will get the so many data. So let's see, now we have seen the all the parameter. Now how much voltage it will started, like it will taking so small duration of the time, it will acquire so many voltage and current. Let's see, here there will be voltage and there will be current. So when voltage is 0, current will be huge, that we have seen here. So it is started from the 82 current. See, here there are so many data, minus 1.72. I will go here, 2000, 2000, 9000. See, here finally we have went to the 24,747. That much data it is acquired in a 2 second. This is lamp 1, when it is flashed in a 1 second, that much data. Again it is lamp 2 data. Okay, like same lamp we are using, it is injected in after 1 second, that is again up to 15,000. Then lamp 3, there I will get the voltage and current again. So until 3 light radiation is incidenting, that much of voltage and current I will get. Yeah, until current becomes 0. See, here current becomes 0. Okay, so that much data I will get. Same thing for the second time. So here you can see that this is test 1, I will go for the test 2. So same day I have taken data. So they are containing the test 1, test 2, test 3 up to test 10. So depending on the company, they are doing the sum of the test. Again they are giving the same data, like it will start from the minus 1.76. If you want, you can compare other things also, like what is the module temperature. Here there you can see, this is test 1, 25.73. Here it will tested for the 25.83. Then what and all voltage, VOC and ISC 16.4 and 8.5. That is also same thing here, 16.4 and 8.5. Then it will start acquiring the data. Let's go down below. Again same thing, minus 1.7, 8.6. Because ISC is current where voltage is 0. So almost same current I should get. See here, ISC is 8.52. During flash test it is generating 8.67. So we will see. So until 0, when current becomes 0, voltage become high, 16.4. Here in top also you can see the VOC. VOC should be getting 16.4. I am getting here. So when current is high, voltage is 0. When current is low, I am getting the same thing. It is for lamp 1. Then this is the lamp 1 irradiation. Here you can see. Okay. Then again we will go for the lamp 2. What is the current during that point? 8.59 here. Okay, here I am getting so many zeros. See, during the second irradiation time, like when 0 happen, same thing. When ISA becomes 0, voltage becomes 16.4. So these are the flash tested data. So like this, what we will get the data of the module. So now only same thing, we can just calling a Python program, we write the program, then we just add this data set and we can plot. So another thing, I will just demo the one of the data sheet that I got it from the one of the database. It is freely available SCADA data, you can get anywhere. Okay, I will demo that data sheet using Python programming. There I will get the actual IV curve. So let's see the one of the SCADA data which I got it for the field measurement data here. Like after installing, so I can go for the previous data also, test 1 and test 2, because I already made the program for this one. So I'm just explaining the field data here. What they did, they have measured the voltage and current after installing the panel in the field. Okay, so here what happened, again same thing, whatever they have measured in the flash test, same is presented here during the field measurement data. So here also they have got the voltage, current and power. Then all the things are the same, like what are the irradiance, array size, cell temperature, tilt angle. So during the measurement, there will be some changes according to the devices. Some will calculate the voltage or current. So program method is same, whether you are taking the previous data or this data. This is called after the installing. So after module installation, there will be some data that is depending on the irradiance. They are measured according to the sun radiation. Let's see what is the irradiance. Yeah, here see. Here irradiance is 19.9 as a standard. Then after that, while measuring, you will get a 906, and also temperature is 47. So these are the measured irradiance and temperature. So I will plot this one. So data name is data, I have given the Excel name. So we will plot here. So what we will do now, we just execute this one. It is already executed. If you want, just 1 second. Yes. Now print the data frame. Okay, I got the data frame, what and all present in that data sheet, 1.7 up to 100 rows. Then again, see, let's open this data sheet. Okay, so from where, yeah, 1.71 to 114, where it is, yes, 148. So there are 100 data sets. So that I have accessed, that I have formed in a data frame. Then if I want to same one row, like I will put it in x-axis, current in a y-axis, then power in a z-axis, or for another plot. So I will that access x-axis first. I will invoke the voltage. So I will just print it that. So now I will got the voltage of length 100. Okay, so I have put the voltage data in a x data frame. So if I want to get about the maximum, like what is the maximum voltage is present, VMP, that is 31.5, that is the VMP point. Then if I again want to current, I will just run this one. So here what I have used, I have used a Python pandas. So in order to call a particular row, I use this ilog function. What is will do ilog function? I previously explained in a Python basics some of the ilog function to access particular row data. Here I have accessed the x. What is the x? From 0 to 100. Which row? First one is indicating 0th row. Second one is indicating first row. Like that is x. This is current. Again, if I want to get the maximum current, again I will print that. See, I got this one, maximum current. Then again I want to print power. I will get, see, again I will get the power. Okay, so if you want to get maximum power, I will just add. So I'm just again running whatever I have written previously. So again I want to plot it that data. So nothing but it is very simple. Import again numpy for plotting a range from where to where I required. 0 to 36 I will give the arrangement plot. Then I will plot x and y. This is gives the IV curve. Okay, see here. So if you want to modify, like you want to add some label, that you can add line width green, you can add color change black. Let's see. So I don't want to save the figure, I will just comment it. See here I got the black colored IV curve. Okay, so like this I can plot. Again if I want to plot PV plot, okay, let's see. Here I got the PV plot. Let's suppose voltage and power. I just indicate the P max where and all I have required. Just saving, this one is not required. Again I will change the color is black. Just execute here. Shift and sorry, shift enter. Okay, so I have got the PV plot. So like this way we can plot a different IV curve of the scatter data. So whenever if you get 100 rows, you can just call, no issue, using ilog function. So another thing, if you want to use open source software, you can use instead of Jupyter book, there will be some of the other compiler also present. They are having separate Google Collider that we can use, no problem. So here I have searched Colab Python 3.7. This is by the Google. They are having the free compiler. So here what and all we have used Jupyter Notebook, that is from the Anaconda package. So similarly Google also having their own compiler, that is called Google Colab. Same thing, whatever you can write here, you can write it here also. See, this is loading, 1 second. So whenever you are opening this Colab, it already containing some of the tutorial. So I will just copy few things. Just, is that possible? Okay, yeah. See, these are the some of the document already present in the Colab tutorials. This is same extension as you can present in the Jupyter Notebook. I am just opening new Colab. I will just use someone randomly used. Okay, I will just copy. See, here you can enter the, see, I am just again I am just running the same thing, it will run. Okay, so let's demo in the other software. So here what happening, it will already containing the inbuilt functions. Okay, plus the one is over. Okay, I will add the same thing, then print data frame. Okay, yes, I will just run here. Let's see. Here I'm getting some of the, I have to, yeah, it is accessed from the Google Drive. It's okay, no problem. I'm just demonstrating the this new software. This is called Google Colab. You can use that also. You have just see here what happened. It can't access this row. So what I have to do, whatever it is present here, this is stored in a Google Drive. So I have to put this data in my Google Drive. So it will take time. So, but you can use this software also, no problem. We have seen the how to do a model IV curve using some field measurement data or lab tested data. So we have generated the model IV curve using these data. So in next lecture what we will do, we will do the sum of the standard temperature coefficient condition. Why that we have to use that one? So there are two reasons. So we already seen the data sheet. What we will do, we will extract that data sheet using single diode model, and again we will plot the different temperature and different irradiation in the actual model. Like in that previous lecture we got the sum of the data that is based on the data sheet. What we will do here, we will overcome some of the error and try to get the as much as accuracy in the plotting. That is done by parameter extraction. What it will do? Parameter extraction, that will do the, like if I want to calculate what is the sum of the series resistance. See, in the flash test you have seen the rs rsh and diode current, that and all we will extract and we will plot using the parameter extraction technique. This is another thing that is mainly used in the research oriented field. That parameter extraction, according to the parameter you can change the module IV curve and module temperature data. So that we will see in the next lecture. Thank you so much.